So today we're going to talk about algebraic expressions and terms. In our objective, students will be able to identify key terms in written expressions and translate them into algebraic expressions. So the truth about math is that math is a language, and it's a way of communicating information. A lot of students believe by the time they get to high school that math is really about 4 plus 3 and using these numbers and memorizing these types of facts. That's actually not true. Math is designed to be a language that communicates information to help you reason about things in the real world. So, what is a mathematical expression? Well, a mathematical expression is a sentence, because math can have sentences too, and I'm not talking about word problems. I'm talking about equations and pieces of math. Those are phrases or the words in mathematics. A mathematical expression is a sentence with a minimum of 2 numbers or terms and at least one operation. For an expression to be an equation, it must have an equal sign. All right, so these are expressions. And these are just numerical expressions, meaning they don't have any letters in them. There's no algebra here. So 12 plus 6. You can see we have 2 numbers, 12 and 6, and they're adding, so we have that operation. So it is an expression. 3 and then parentheses 12. When we have those parentheses, we know that we're multiplying the 3 times the 12. And then the next one, we have more than one operation, but that's okay. That's still a numerical expression. In the fourth one, same thing. You can see different numbers, different operations, still an expression. The last one has 2 numbers. It has a 5 and a 2. But there's not an obvious operation there. It's an exponent. So with the exponent, you are raising to a power. Technically, that is also an operation. You'll see those exponents a lot more, I think, in this class than what you've seen in middle school. All right, so a little bit of a checkpoint. Which of the following is not an expression? I'll give you guys a minute to think that over. Okay, let's take a look at what you guys did. So we have 5 plus 2, we have 4 times 9, we have 3, and we have 10 minus 20. Most of you guys said it was 3, and good job, because it is 3. To have an expression, you need to have more than one term, more than one number, and there has to be some sort of operation going on. Do remember that when you have something in parentheses, 4 parentheses 9, that means to multiply. And with this one, 5 plus 2, there's 2 numbers we're adding. So, but nobody picked D, that's good. That was the answer second period liked, that if they didn't get it correct. All right, let's talk about what a variable is. In the expression 12 plus b, the letter b is a variable. A variable is a letter or symbol that represents an unknown value. So I always tell this story every year. I am a big fan of Jason Momoa. I thoroughly enjoy his work. I've been a fan of him for years. Like before he got super popular, he was on a show called Stargate Atlantis. And I enjoyed his work on there. He played a really cool character. And, I've seen him in interviews. He's a really funny guy. And, he just seems like somebody that'd be cool to chill with. And most of my friends know I really like Jason Momoa. So I could see, my birthday's coming up now. I could see one of them buying me a cardboard cutout of Jason Momoa. Now that'd be cool to have, I guess. I don't know what I'd do with it. But I'd probably find a spot for it somewhere in my house because I enjoy his work and I'm a big fan. That's a replacement for the real thing. It's a stand-in, and that's what variables are. Now, if Jason shows up at my house, knocks on the door, maybe his car broke down outside, which is unlikely based on the fact that I live kind of in a weird place. But let's just say it happened. And he knocks on my door. That cardboard cutout's going out the window. It's getting in the trash. I don't want him to see it because that'd be embarrassing. He would know I'm a total fangirl when I'm trying to play it cool. So when the real thing shows up, we get rid of that stand-in. It's the same thing in math. When we have a variable, it stands for a number. We don't know what that number is. I don't know where Jason is, but like once I find him, I'm getting rid of the cardboard cutout, and then we're going to be best friends. And that's just how that works. So I would replace that stand-in with the real thing. The number is the real thing. And I know that clicks for some kids some years, so I'm going to throw it out there. Maybe it'll help one of you, or hopefully all of you, really, if you're not getting the point of variables yet. Algebraic expressions. When variables are used with other numbers, parentheses, or operations, they create an algebraic expression. So we have a plus 2. You can see our variable in this one is a. We have a times b. You can just stick those two numbers together as well, but with the parentheses, we also know we're multiplying. And then we have 3m plus 6n minus 6. All of those have a variable in them, a letter in them. So I would like all of you to take a minute and write an algebraic expression. So let's take a look at what you guys did. Y equals mx plus b? Absolutely. And we're going to be talking a lot about that in a couple weeks because we're heading into linear equations soon. So that's an awesome example. This is perfect. Great. I love it. Yep, you can have an equal sign in an expression. It also will be an equation, but all equations are expressions. So that's totally cool. You can totally do that. That's awesome. And here's this child here who is being above and beyond. And all of these are great examples of algebraic expressions. Excellent, excellent. Yeah, this looks really good, guys. And I'm sure this person was going to get there. You could have added any number. You could have added a different letter. You could have put pretty much anything after that plus sign. So you definitely were getting there. All right, so what are coefficients? A coefficient is the number multiplied by the variable in an algebraic expression. So we have the expression 6m plus 5, and our coefficient would be 6. You have the expression 8r plus 7m plus 4, and your coefficients, in this case, are both 8 and 7, because 8 multiplies times the r, and 7 multiplies times the m. So both of those two numbers are coefficients. And then in our last problem, 14b minus 8, 14 is our coefficient because it is multiplying times that b. So quick check. What is the coefficient in this expression? All right, let's take a look. So the class was kind of divided over 3 and 7. Most people, it looks like, picked 3, but we did have more than one person pick 7. So the correct answer for this one is 3. It is simply the number that's in front of your variable, the number that's multiplying times that variable. All right, what is a term? A term is the name given to a number, a variable, or a number and a variable combined by multiplication or division. So algebraic expressions, we have a plus 2. We have the terms a and 2. There's two different terms. We have 3m plus 6n minus 6. 3m is one term because they're stuck together like a little family. So they're a term. You could also have m over 3, like m divided by 3, and that would be its own term. Yeah, but when they're stuck together with multiplication or division, even though there's two things there, they're one term. All right, so quick check. How many terms are in this expression? All right, so most people pick 4, and 4 is good. This has 4 terms because You have 1 term, 2 terms, 3 terms, 4 terms. You couldn't combine any of those things. X squared and x are different terms. But remember, these are next to each other. So this is all 1 term. So you don't count like 1, 2, 3, 4, 5. I know some students do that. But this is a term. This is a piece of the equation that, is its own piece. That's all a term really is. All right, what are constants? A constant is a number that cannot change its value. Or in other words, it's just a regular number. In the expression 5x plus 7y minus 2, the constant is -2. And do note that you have to take the sign in front of the term you're talking about. In this case, we're talking about a constant. Constants are also terms. They're special terms. They're just numbers. But it's not 2, it's -2. You got to grab that sign that's in front of the number. All right, quick check. What is the constant in this expression? All right, most people said 3. Good job. It is in fact 3. Because all you had to do in this one was look and see where's the number that doesn't have a letter. And that's your constant. A number. When you see a phrase that refers to a piece of information that you do not know, that's when you will use a variable. The phrase a number is often used to indicate a variable. After all, a number is talking about some number that we don't know what it is. So we're going to talk about some keywords. Addition. You can have add, plus, sum, total, increased by, more than. So basically any kind of number or any kind of word or phrase that indicates that something is going to go up by a certain amount, you're adding. All of those things, increased by especially, you're adding. And then subtraction, minus, difference is a big one. Difference you see all the time in word problems. Difference definitely means subtraction. Subtract, less than, decreased by, less. All of those words. And I've also added a graphic organizer to Google Classroom. You can find it under Teacher Notes and Graphic Organizers. There's a section where you find your assignments. You scroll down further. There's a section that has that stuff. And I put in a graphic organizer about this stuff already. So you can certainly pull that up if that will help you. Then that will help you. All right, what operation should we do? A number is increased by 3. All right, most of you guys said addition, good job. Subtraction, nope. Subtraction's all about numbers getting smaller and taking away from the numbers. And this one said, increased. So we're going up, we're not subtracting. And not enough information to know. Sometimes they throw stuff like that in there to trick y'all because they do that kind of stuff on the PARCC exam or MCAP, whatever we're calling it now. And yeah, so we do have enough information to know. But some kids kind of see this type of answer and they think, oh, well, if that's there, that's one of those weird answers and I should pick it. So sometimes I try to trick you guys. All right, let's talk about multiplication and division. So multiplication, per is a big one. Per and each are both big ones that we're going to see as we get further into our word problems. We're going to see per and each quite frequently. Every shows up pretty often. Doubled and tripled are big ones. Doubled is special because it's multiplied by 2. Tripled is multiplied by 3. And then of we see a lot with fractions. So 3/4 of a number would be 3/4, and then you could use whatever letter you wanted for your variable. And then division, we have quotient and divide. Some of these, not double, triple, some of these can technically also mean division, but not usually. Not usually. You should think division when the problem is calling for splitting something up into groups. That's when you might use division. So you're going to have to really think about the problem you're reading and think about, am I splitting stuff up or am I making, things bigger? Am I adding groups? Adding groups is multiplication. Division is splitting something into groups. All right, so quick check. What operation should we do? Double a number. All right, and most of you guys pick multiplication. Good job. Not enough information. We do. When it says double, it means to multiply by 2. It's a very specific word where it always means multiplication and it always means to multiply by 2. All right, writing algebraic expressions. You can translate word phrases into variable expressions. For example, 3 more than a number means you'd have x, or whatever variable you so choose. You have x plus 3 because you want to take that number, that mysterious number, and make it 3 more, so you add 3 on. The quotient of a number in 8, so it's y in this case divided by 8. 6 times a number, you get 6n. So remember, when a number and a letter go next to each other, they are multiplying. 15 less than a number, so you have your mysterious number that you need that cardboard cutout for, z, and you're taking 15 away from it. And the quotient of 30 and a number plus 10. So we have the quotient of 30 and a number, 30 divided by x, and then we're going to add 10 on at the end. Okay, so write an expression, 4 more than a number. Let's see what you guys put. So 4 times a, nope, we want 4 more. You want to take that number and increase it. So let's say you had $10 and you wanted to increase it by $4 more, right? You would add those together and you'd have $14. That would be how you'd get 4 more than the original number, which I just randomly picked 10. Like this one's perfect. X plus 4, great. Don't pick your own number. The whole point with word problems is there's something you don't know. And once you've translated that into mathematical language, you can move forward and try to figure out what number should be there. But it's not up to you to pick the number. 4 plus 5, x plus 4. So some of you guys got it right. And as I said, we will continue to look at this next class. So a quick summary. A mathematical expression is a phrase with at least 2 terms and at least 1 operation. Writing mathematical expressions from verbal expressions is simply a translation into mathematical language to better work with the information. Keywords in real-world scenarios tell us what the mathematical operations are. And as I said, we will continue this journey on Monday. So, how do you feel about today's lesson? Once you've answered this question, if you don't have any questions for me, you can feel free to hop on off of Zoom. Except Mark, hold on a minute. I don't want you to leave yet.